let's start with chapter 3. Let's see what's the control rectifier DC drive system. So simply here I'm assuming that my supply is AC, correct? And I need to control or drive a DC machine. So in this case, I end up with two options. The first one is to use the control rectifier, and the second one is to use what? The uncontrolled rectifier cascaded by a DC to DC converter, which chapter 4 will be. So now I will discuss with you the controlled rectifier DC drive. So simply this is a block diagram now here. And I'm assuming that I'm having a control rectifier for the armature circuit and also for what? For the field circuit. Here by assumption, I'm assuming that I need more power for the armature circuit, so I can use either 3-phase or a single phase control rectifier. The same thing is applicable, by the way. I can use here a 3-phase control rectifier, but in general, I don't need that power for the feed circuit. So in general, we are using what? A single phase, let's say, control rectifier for the feed circuit. Now here I'm having two feedback control signals. The first one is what? Current. The current. And the second one is what? Speed. And TG is what? Tacho generator. It's a tacho generator, huh? Speed sensor. Now here I'm having control and firing angle, and simply it's responsible to give what? The firing angle not only for the armature, let's say, control rectifier, but also to the field. So here I can add so here let's say alpha A, and also I can give alpha F, which will go to here. So I can control the field circuit and I can control the armature circuit. And if I recall, if I need to control the speed below the rated, in this case I need to give a firing angle such that the voltage here is what? Rated. Is the rated. Yeah? Good. Now I need you to understand one thing. The direction of the current here is already decided by the direction of what? Of the arrow. You see the thyristor? There's an arrow. So simply this means that the only way, the only possible way for the current to flow is in this direction. Yeah? The same thing here. The only possible way to flow is what? To this direction. If I need to reverse the direction of the current, what I need? I need to reverse the direction of what? Of the converter. Yes? Understood? This is very important. And for that here I'm using, let's say, arrow. And I'm telling you that the current flows only in one direction, which already decided by the direction of what? Of the arrow. Understood? Good. You cannot make the current flow in the opposite direction. Okay. Now let's recall the single phase half wave drive. Here simply I'm having only one switch, one thyristor. And you know that the thyristor will conduct, when the thyristor will conduct? When the current will flow via the thyristor.
عند الفايرنج انجل بي اس
The first condition, the anode must be more positive than the cathode. Then it must have the fire. If you are firing the thyristor before the forward bias, it will never conduct. It will be self-committed. It will turn off. So simply, it will conduct if the anode is more positive than the cathode, which is the forward bias, and you have what? Gating and holding current. And remember, all the time I'm assuming that I'm having ideal switch, either on or off.
Okay.
Oh, good. So simply let's assume that I'm having constant flux, constant speed, and in this case EA will be what? Constant. Why? The back EMF is proportional with the flux, yes, and the speed. Correct?
Yes.
If I'm assuming that the flux is constant, because I'm not controlling the flux here, I'm controlling the armature circuit, and I'm assuming that the machine is rotating at constant speed. I'm discussing that point, huh? I'm discussing that point. And I need to plot the curve. So in this case, I'm having the supply waveform, which is the Vs, and I'm having a constant line, which is what? The back EMF. And here I'm having, let's say, two angles. One I call alpha, which is the firing angle, and the other one, or the end, I will call beta. Now simply this means what? I will gate or fire the switch at alpha. Vs is positive or negative?
Positive.
So I am in the forward bias, correct? Yeah? So the current will flow, yes? Now the current will flow, it will not stop at pi. Why? Because I have inductor. This will do what? Extension for the firing angle, extension angle. So beta is what? Is the extension angle. Good? Now beta minus alpha is called what? The conduction period. Yes? Good. And this will repeat what? Every cycle. Now, here sometimes it's impossible, or not impossible, let's say, it's very difficult to achieve continuous current, yes or no? Yeah? Of course, if I need to achieve such kind of continuous mode of operation, the inductance must be very, very, very high. Yes? And this in general what will be very difficult for the single phase. Now let's see what will happen for the V terminal and what will happen to the current. The same graphs, except now I'm plotting the V terminal. Yeah? I'm plotting what? The V terminal, which is what? The blue line. And I need to find in the end of the day the average value. Yes? Okay. So I need to do what? The average value is the area under the curve, so I need to do what? The integration. So here I can, let's say, divide the curve in two curves. The first one, I will integrate from alpha to alpha plus beta, and the second one from alpha plus beta, from beta, let's say, until 2 pi plus beta. Because this one is constant, yeah?
Yes.
Yeah? And you know that if I need to do so, I can use step function, which is the what? U of alpha, or U of beta, or U of t. U of t is equal to 1 when the time is greater than 0. So U of alpha will equal to 1 when the angle greater than what? Than alpha. U of beta will equal to 1 when the angle greater than what? Than beta. So if I need to represent the voltage, so the V terminal here will equal to what? The first one, it will equal to V supply when between alpha and beta. Yeah? And remember, I'm using the step function, which is U of whatever alpha. This will equal to 1 if omega t greater than alpha and 0 is. So this is actually what? A step function. So this is actually a pulse, by the way. Here, U alpha minus U beta is a pulse function, yeah, which will equal to 1 between alpha and beta. Then I'm having the remaining part, yeah, which is the constant from here to here. Yeah? Now, in general, I'm having the supply, which will equal to what? Vm sine omega t. And let's plug it here and do the math. Now, in general, Vt will equal to what? Vt will equal to Va plus Vl plus the drop voltage after that. I'm interested in what? In the average value. So, Vl average will equal to what?
0.
0. Yeah? Vl average will equal to 0. So this one will equal to 0. So I will end up with what? Vt average is equal to AA plus I average RA. Now let's do the integration for Vt average. Replotting here. Now I'm doing the integration. So here the integration between what and what? The first one? Between alpha and beta, where V terminal is equal to what? To V supply. Correct? And between beta to alpha plus 2 pi, when Vt is equal to what? EA. Now if I do the math, this will be, and this one should equal to what? EA plus I average RA. Now, if I define gamma, which is the conduction period, as beta minus alpha, simply I will end up with the following equation. Now I can rearrange this one here, okay? And I will do the integration here. So I will get what? B max over 2 pi, yeah, cosine alpha minus beta. And in the second part, I will get gamma over 2 pi EA plus RAI average. So simply now I'm having here what? This can be seen as V terminal, as average value. And this can be seen as what? The effective back EMF. And this actually is what? Is the average. So simply, I can rearrange it as, in the end of the day, I can control the speed by controlling the V hat, which actually V max over 2 pi cosine alpha minus cosine beta. And here, there's a modification for the back EMF constant due to what? Due to the discontinuous mode of operation. Now, let's solve the first example. Here I'm having what? 1 horsepower DC shunt motor is loaded by, let's say, a constant torque of 10 Newton meter. RA is 5 ohm, and simply I'm having a constant field, which is the 2.5 volt second per rad. And I'm using the silicon control rectifier converter in order to control this one. The supply is 120 volts, 60 hertz. Alpha is equal to 60 degree, and the conduction period is equal to 150. I need to calculate the motor speed and the developed power. How I can do that? If I recall back here, see what I'm having. 2 V max. This one's given. Yeah?
Yes.
This one?
It's given.
It's given. This one? This one's given. So I can calculate this one.
Yes.
Yeah?
Yes.
So simply, this one, RA is given. Yeah?
K5.
I need to calculate what? IA average. This one I will calculate from where? From TD. Yeah? TD is equal to what? K5. IA. So IA is equal to TD over K5. TD is 10. K5 was what? 2.25. 0.25? 2.5. So this will equal to what? 4 ampere?
4.
So this one is given. So the only one missing is what?
Omega.
It's omega. So it's plug and play. Yeah? So I can solve it. So the first thing here, I'm calculating the current. After that, I'm plugging and playing with the numbers. And in the end of the day, I rearrange it and I'm finding omega. And if you need to write it or like to write it as RPM, you can do that. The second one is what? The developed power. The power developed equal to what? EA? IA. Now let's see. IA is given? Yeah, we already found it here. EA? We can find it. Now the missing was what? Omega. So EA will equal, remember that K5 is given volts second per rad, correct? Which is the 2.5 multiplied by 1, 6.22. So simply the power developed will equal 2.5 multiplied 1, 6.22 multiplied by 4, correct? So this is also a straightforward problem. Yes? Good. Until here, do you have any question? Okay. Now, let's discuss the single phase full wave drive. And in general, we are interested in the continuous mode of operation. So this is, let's say, the converter. Let's say, big picture. Huh? So simply here, I'm using what? Single phase, full wave, controlled rectifier. The circuit inside this one is actually 4 switches, 2 legs. So simply, So simply here I'm having what? Switch number 1, switch number 2, 3 and 4. And T1 and T2 is conducting together. So in this case, the current will be what? Flowing in this direction. All the time the current will flow in the same direction. Huh?
Yes.
But simply, if I switch on, let's say T3 and T4, what will happen? The voltage will be reversed. Good? Yeah? So simply here, the current is positive, while the voltage can be reversed. Correct? So reversing the voltage is the meaning of what? This means that the positive area and the negative area, I can control the positive area and the negative area. If I can control the positive area and the negative area, if the positive area is higher than the negative area, then the average value will be positive. Yes. If the negative area is higher than the positive area, then the average value will be what? Negative. So in general, this means that the current all the time is positive, while the voltage can be either positive or negative. Correct?
Yes.
Okay. So let's see. So simply here I'm having a supply, yeah, and here I'm getting at certain, let's say angle alpha. So in the positive cycle, T1 and T2 is conducting, yeah. Then the current will flow from T1 through the motor and return back to where? T2. In the negative cycle, I'm firing or conducting what? T3 and T4. Yeah? T3 and T4. Yeah? Now the same thing, the current is still positive, while the voltage will be what? Negative, because I am in the negative side. No? Now here alpha greater than 90 or less than 90. See the area. Which area is larger? The positive area or the negative area?
Positive.
So alpha less than 90. Correct? So this plot for what? For alpha what? Less than 90. Now if you look here, this is what? The IA, the IDC. I'm assuming it's ripple free. This assumption that I'm having high enough inductance such that the current is ripple free. Yeah? Good. So simply this will be the supply. Correct? If this one is the output current, then if T1 and T2 is conducting, then I will take the positive current from the supply. If T3 and T4 is conducting, then I'm having the negative. So in this case, the supply current is what? Square wave. Has harmony, of course. Huh? Now what about if I'm increasing alpha higher than 9? What will happen?
Negative average.
Now here alpha for sure, actually here alpha is equal to 90, I think.
Yes.
No, higher slightly than 90. Because if 90 it will equal to 0. Yeah. So in this case, I'm having the negative area is larger than the positive area, so the average value, which is represented by the dashed line here, is negative, correct? Yeah? But all the time the current is what? Is positive, correct? Good. And this one for alpha what? Greater than by oh. Yeah? Do you have any question until here?
دكتور بس يكون ال average output voltage negative الكرنت positive ايش هاي المود of operation
Q4. Except that the machine must be rotated in the reverse direction. Why? Because it's impossible for the machine to be rotated in the forward direction, yeah, and the voltage will be negative. Yes? It must be rotated in the negative direction. So how come this will be in one mode of operation? By the way, the mode of operation is connected together. So I cannot say that now the machine is operating in reverse direction. Yeah? It operated there because there's something happened and put it there. Yeah? So this means that this converter can support the machine in 2 quadrants only. Yes? In where? In Q1, when the voltage is positive and the current is positive, and in Q4 when the voltage is negative and the current is positive. So simply, this means that I have it here. No, I have it somewhere. This is. If I do the integration, then the average value will equal 2V max over pi cosine alpha. By the way, I can calculate it from the first one. It was V max over pi cosine alpha minus cosine beta, correct? Now beta will equal to what? Alpha plus pi. If I substitute there, I will get what? Twice the area. Yeah? Twice the area, so I will multiply here by 2. Huh? So this will be 2 V max over pi cosine alpha. If I need to plot this one, so I will plot this one as a function of what? Of alpha, as a function of omega t. So the first thing, if alpha equal to 0, what I will get? 2 V max over pi, the maximum. Yeah? Yes?
Yes.
Now, if alpha equal to pi, it will be the negative. Yeah?
The maximum.
Negative. The maximum in the negative direction, or the opposite side. If alpha equal to 0, if alpha equal to pi over 2,
0.
yeah? So simply it will take the shape of what? Of the cosine. Yeah?
Yes.
It will take the shape of the cosine. So if I need to plot it, here alpha is equal to 0. So this point is 0 alpha 0 volt. 0 alpha and the maximum. If alpha equal to 0, then the voltage will be the maximum, which is 2V max over pi. And if alpha equal pi over 2, then the voltage will equal to 0. And finally, if alpha equal to pi, in this case, I will get it to the minus 2V max over pi. Good? So simply, this means that all the time, the current is positive. Why the current is positive? The direction of what? Of the arrow. You see? Direction of the arrow. And the voltage can be positive or negative. Yeah? So simply, this means that this converter can support Q1 and Q4 mode of operation. Yeah? In Q1, the machine will be rotating in the forward direction. Let's assume this is the forward direction. So this will be plus minus EA. And this will be the current here, IA. And here plus minus VA. This Q1 mode of operation, which is the motor, forward motoring.
Yes.
Yeah, Q1. Huh? And in Q4, what I'm having, in this case, the machine is rotated in the opposite direction. So this will be minus plus EA. Yeah?
Yes. Current same direction.
And the current is flowing in this direction. This is the IA. And because all the time the current is what? Is decided by what? By the direction of the arrow. So, what about if I need to write the armature current? IA will equal to what? Now we know that VA is equal RA IA plus EA. So simply, if I need to find IA average, it will be, let's say average, it will equal to what? VA average minus EA over RA. Now what about if I'm using a single phase full wave converter for the field circuit? V alpha will equal to what? Here, this one is what? The armature volt. Yeah? So, simply someone will say it's logical to say that this is alpha A. Huh? Yeah? Because it's what? For the armature. Now what about if I'm using the same converter, another one, huh? But for what? For the field circuit. Who can give me the average value for the field voltage? Except that A will go to V. Yeah? So simply, if I need to write, if I'm using a single phase, full wave converter to drive or to control the voltage for the field circuit, in this case, VF, I can write it. What? Very correct. Will equal to 2 Vmax over pi cosine alpha f. Correct? Very simple, very straight. So can I change the direction of rotation by changing the direction of the field? Yeah, the current nafsu. So I cannot, huh? I cannot. If I need to do, I need to use dual converter. Dual converter connected in anti-parallel configuration. Later on we will discuss that. Remember, I cannot change the direction of what?
Current.
Of the current. Yeah? The direction of the current is already decided by the direction of the switch. Another example. Who will help me with that?
Yeah.
Yes, please. So simply, we have a separately excited DC motor, and it's driving a constant load. Huh? The motor is driven by full wave converter, 120 volt AC supply. The field constant of the machine is 2.5 volt second per hour, and RA is equal to 2 ohm. I need to find the firing angle so that the machine is operated at 200 RPM. Of course, here I don't need to think about the ripple. I'm assuming that I'm having sufficient inductance such that the DC current is ripple free, or the current in the motor is ripple free. So how I can solve this one? What I need to calculate? I need to calculate VT or VA average, correct? Yes. Now, if we recall, VA was equal to what? RA, IA plus K phi omega. Omega is given?
Yes.
Yes, it's given. K phi is given?
Yes.
Yes, given. The current
Not really.
from the chart, thank you. Yeah. So here I can calculate IA TD over K phi. So it's given indirectly. RA is given?
Yes.
So I can calculate what? VA. So VA, remember, this is a full converter single phase equal to what? 2 V max over pi cosine alpha. So if I need to find alpha, this will be what? Cosine inverse of 2 V max over pi. Correct?
Yes.
Yeah? Sorry.
2
VA over 2V.
It will be cosine inverse of VA, and now multiplied by pi over 2Vm. And VA is what? Is equal to this one. Yeah?
Yes.
So straightforward. Yeah? So let's see. So the first thing, this is what we written, it's already the alpha is equal to cosine inverse of pi over 2V max, RA T K phi. Oops. So if I do the math, it will equal to 1.7 degrees. Yeah? Let's record it here. VA was equal to V max over pi cosine alpha, and this will equal RAIA plus K phi omega. So simply, if I need to find this one, the first thing, VA, what I'm having this one, I'll multiply it by pi and divide by 2V max.
Yeah.
Then I will take the cosine inverse for this one, correct?
Yes.
And this is what we did. Now I will record, this one is already given, but it's given n, huh?
Yes.
Huh? So you should what? Convert it to what?
Right.
To right, and we know that, huh? So omega equal to what? Pi over 30 multiplied by n.
Oh.
Yeah?
Yes.
And k phi is given, yeah?
Yes.
IA, we can take it from TD, which equals k phi multiplied by IA. So simply here, IA is equal TD over k phi. So this one is given, and R is given, and all of those are given. Yep.
Yes.
Now, this one here is the maximum value. What's given in general is the RMS value. So you should multiply it by square root of 2. So in general, if we give a supply, unless I'm telling you something else, it will be what? The RMS value. The RMS value for the single phase, line to line, RMS value for the three phase. Good? Unless I'm telling you something what? Else. Now, sometimes I need more power. So more power, this means that I need to go to polyphase. So instead of the single phase, I will go to the three phase full converter drive system. The same thing here. I'm having the first one as one block, single thyristor, decide the direction of the arrow, and inside this one I'm having 3 legs. Each leg has 2 switches. So in general, I will have 6 switches, number from T1 to T6. And I need what here, a firing angle, so this one, if connected to the armature, it will be alpha A. Yep. So here I'm having T1. If the current will flow via IA, the only possible scenario to go from where as a positive T1. In the negative T4. Yeah? IB, the positive direction via what? T3, and the negative direction via what? T6, and the same thing for what? For the RC. Now, in general, if I need to find the average value, it will be 3V line to line max over pi cosine alpha A, because here I'm assuming this one is connected to the armature. And if because all the time I will give you line to line RMS value. So if I convert it, it will be 1.35 V line to line cosine alpha A. Yep. And if I need to plot this one, it will have the same shape as the single phase, except that the voltage are amplified. Yeah?
Yes.
The same thing here, I'm having positive and negative, according to what? To the alpha. So if alpha less than pi over 2, I'm having
Positive
average. And if alpha is greater than pi over 2, I'm having what? A negative. So it will support the machine in Q1 and Q4 mode of operation. Now, let's refresh. This will be the same if I need to calculate the current, the armature current IA average. It will equal to VA average minus EA over RA. And if I'm using the same converter for the field circuit, in this case I will have VF will equal 1.35 V line to line cosine alpha. Now, let's see how this converter is operating. Now, here I'm assuming that I will do firing at pi over 6 for T1. Then I will fire the next switch at this, let's say, instance. And the same thing here, I will fire the third switch. And here I'm having the voltages, the VA, VB, VC, and I'm having the V line-to-line voltages. Now let's see. At first, let's assume that at first I will conduct or I will fire T1. But before T6 was conducting because this is a cycle.
Yes.
Yep. So similarly here, at this instant, I'm firing Q1, which is switch number 1. But remember that also Q6 was conducting. So similarly from here to here, what switches are conducting?
T1, T6.
T1 and T6. So the current will flow via
VA.
T1, the machine, and return back
T6.
V6. Correct? So similarly, if I'm assuming that the current is ripple free, so IA will equal to what? Certain current, which is the IA, as a square, correct? Yeah? And this one is 60 degree. Yeah, because I will fire each 60 degree. So this is the first one. So which V terminal, the voltage that the machine will see is what? VAB, correct? The machine will see what? The VAB, which is the VA minus VA. So the machine will see this one. Yeah? Now, in the next stage, what I will do? In the next stage, I will turn on Q2. I will turn on Q2. Now, if I turn on Q2, what will happen to T6? Why?
First.
Huh?
The first part. Yes.
It will be force commutated.
Yes.
Yeah? It will be force commutated. Now, so in the next time span, let's say, T2 is on. Now, VCB will appear as T6. Huh? Now, T6, it will see what? The VCB. Now, VCB is higher than, it will do a reverse bias for the switch. So simply, T6 will be off, and the current will flow where? Via T2. Yeah? But still, the same current is flowing in the first switch. So simply, this means that each switch will conduct for 120 degrees. Yep. So this is IA. If I need to plot IB, it will be the same shape shifted by 120 degrees. If I need to plot the IDC or the I line, or this one, the voltage. Yeah, this one will be the I line. Yeah, this will be the I line, which is the let's say the compositions of the IA, IB, and IC. Now let's take example. I think I have an example here. Now here I'm having a three-phase full converter is used to drive 100 horsepower, 600 volt, 1,800 RPM separately excited DC motor. The converter fed from 480 volts. This is what? Line to line RMS current. 60 Hz supply. The field constant of the motor or the backing of constant is 0.3 volt per RPM. Here is given as volt per RPM, not
Volt per
yeah. So this one I cannot use directly to calculate the torque if I need to calculate the torque. And RA is what? 0.1 ohm if the motor draws 130 ampere, and I'm assuming triple free, and runs at 1,500 RPM. I need to find the firing angle. So simply the firing angle, if I need to find it, I know VA, this one is equal 1.35 twice. V line to line, cosine alpha. So if I need to find alpha, it will equal to 1 over 3, 1.35 line to line, VA, cosine inverse. So I need to calculate VA. Yeah? So VA equal to what? We know that VA equal to what? Equal to what?
400
اسمك ايش؟ أسامة. VA equal to what? RA IA plus K5 omega. Yeah? RA is given? I think it's given 0.1. multiplied by IA 130. It's given, huh? It's 130 on this one.
Yes.
Let's fix it. Plus the back EMF, this one the back EMF, EA, equal to what?
أطول.
Yes.
Direct.
Why? Because you don't need to do two convergent.
Yes.
If you convert the first one, you should convert the second one. In the end of the day, the back EMF is equal to what? K phi omega, or K phi described as volts second per RPM multiplied by N. Okay? So I'm giving you all the tricks, by the way. It's not tricks, but just. So if I do the math, calculator, because this one I don't think I have. 450, huh? 450?
Yes.
Plus
لا.
50.
463.
This will equal to what?
15 plus 450.
Yeah, so 463, yeah? 463 volt. So now we can find alpha. So alpha will equal to cosine, I think, cosine inverse of 463 over 1.35 multiplied by 480, the line to line. And if we do the math, this will equal 44.4 degree. It must be less than 90.
Yeah.
Why? Because I need the voltage to be positive. Huh? Okay. Now the second thing I need you to calculate is what? Determine the supply power factor. The power factor. How I can find the power factor. Now do you remember the power triangle?
Yes.
Yeah? This is what? This is what?
We have Q power.
And this is what? Yes. Which side? I need to calculate the input side, correct?
Yeah.
So this will be what? The power input. Yeah?
100.
Yeah?
Yeah.
And this will be what? If I need to find theta, this theta. Theta will equal to what? Cosine inverse of P over S. Correct? Yeah. Now, let's record. Do you remember all the time I'm telling you that if I'm using switch, it will be ideal switch?
Yes.
So the power input to the switch, to the converter, sorry, is equal to the power out from the converter.
Yes.
So which easy to calculate the power on which side? The motor side or the input side? The motor side. Why? It will be called VTIA. So, yeah. Yes. Good. So simply here, the power, I think I'm having space. Yeah, I think I have space. So the power, Pn is equal P out from the converter. No? Otherwise, this will be the efficiency equal to 1. And I'm assuming that the converter is lossless, no? From the converter. Why? We assume lossless switches or converter. No? So simply, the P out from the converter, let's say converter here, will equal to what? V terminal or VA, IA, correct?
Yeah.
And VA was 463, I think.
463.
463 multiplied by IA, which is 130, it's given, huh?
Yeah.
So if we have the math, we can calculate this one to be 60190. 60191. Now I need to calculate what? S, huh?
Yes.
We have
I need to calculate this. S is equal to what? S is what, by the way? S is the apparent power. So it's a magnitude.
Yes.
Don't say V multiplied by I conjugate. I know it's V multiplied, but this is a magnitude, huh? So VI. V supply multiplied by I supply. V supply is given. So only I need to calculate what? I supply. This is what? 3 phase. So if I have 1, I will multiply by 3. Yeah? So I will say that it will equal 3 VA I.
Square root 3.
RST, I think I call it. The input, it was what? RST. Huh? So in this case, the S will equal 3 V phase, I phase. This will be more logical. Good. V phase, we have it, I think. V phase, we have it, which is the 480 over square root of 3. It was line to line.
Yes.
This about, huh? Now I need to calculate I phase. Now remember, each switch is conducting by what? 120 degree. And if I recall the waveform of the current, this is the IA. You see it?
Yeah.
So if I need to do here, I will do the integration. Yeah?
Yes.
From here to here, and I'm having what? In order to find the effective value or the RMS value, correct? Yeah? So let's do the integration in order to find the RMS value.
ممكن تدرس 2 و 3 صح؟ مباشرة ولا لا؟
Yeah, it will be. Okay, if we do the integration, so if we do the integration, this will be the square root of 2 over 3 multiplied by I dc or IA. So now we can calculate S, and if we do the math, S will equal to 881, I think 881, 69.1. 69.1. Now theta is cosine. I need cosine, I need the power factor, right?
Yeah.
Yes.
So I need cosine theta.
P
Yeah, cosine theta is equal to what? P over S. So this will equal to 60190 over 88169.1, and this will equal to what? To 0.68. Lead or lag?
لا
lag.
مش مفروض مرة ليد ولا لا؟
لود لا
Now simply, if I plot this one with VA, VA appear before the current.
ما هو
Yes.
ما كان قصدي.
This is the meaning. This is the meaning. So all the time, VA will appear before the IA. So it's what? It's a lagging factor. Right? Okay. Do you have any question until here?
No.
No? Okay. Let's see. Now, what about if I need to achieve the 4 quadrant mode of operation? Which means that I need to support the machine in Q1, Q2, Q3, and Q4. What I should do?
نصير converter ثاني مقلوب.
Yeah, I need to find a path for the negative current. So the only way I can do that is what? To flip or to connect two converter in anti-parallel configuration. Yeah? So, this is a configuration, yes?
Yes.
So here I'm having 2 converters. Converter number 1, converter number 2. By the way, this is also applicable for single phase or 3 phase. It will be the same. Here, I'm assuming that I'm having what? High power 3 phase system. Huh? So here, it will be what? Alpha 1. And this will be what?
Alpha 2.
Alpha 2. So alpha 1 is the firing angle for the converter number 1. And alpha 2 is the firing angle for what? Converter number 2. Yeah? Now, this converter can provide the current in this direction. And this converter can provide the current in the opposite direction. The 2 converter can provide plus or minus voltage. Remember, VA was what? VA will equal 1.35 V line to line cosine alpha I, let's say, to be I1 or 2. So converter 1 will be supporting the machine in Q1 and Q4. Why? Because the voltage can be positive or negative, but the current is what?
Positive.
Now, in general, if I need to decide or to say anything about positive or negative, I need to fix my reference. Yeah? So all the time, this is the positive sense.
Yes.
Yeah? So positive for this converter, negative for the second converter. Yeah? If I'm changing the reference, I cannot say anything. Huh? Good. So converter number 2 will support the machine when? Where?
Q2.
Any Q2 and Q3. Yeah?
With negative
Q3 and Q2. Q3 is what?
اللي هي negative current negative voltage.
Negative current, negative voltage with respect to the machine.
Yes.
But it's actually positive current, positive voltage with respect to what?
Converter
To
2.
the converter. Yeah?
Yes.
Yeah, that's why I put Q3 before Q2. Yeah? Yes?
Yes.
Good. Now, you know that if I'm supplying or connecting two supply together, I should respect what? Eh?
Set a reference.
The voltage. Yeah? The voltage. So, simply if the first converter is producing, let's say, a voltage called V1. So this will be the plus sense and the minus sense of V1, correct?
Yeah.
The second one will produce a current, a voltage, V2 in this sense. Yes? Yes?
Yes.
Yes? Yeah. This is the positive for this one.
This one.
This is the positive for this one, and this is the positive as a reference. So, in order to prevent short circuit, or short circuit actually is circulating current, then the loop voltage must equal to 0. So V1 plus V2 must equal to what? 0. Yes. So simply, in order to prevent short circuit or circulating current, then I must obey. Where is it? Correct. V1 plus V2 is equal to 0. So I must find a relation between alpha 1 and alpha 2. Now let's see. V1 is equal to what? Who can give me V1? V1 is equal to certain constant, which is 1.35 V line to line cosine alpha 1 plus V2 equal to what? The same constant. 1.35 V line to line cosine alpha 2 must equal to 0. And you know that this can be reduced as cosine alpha 1 plus cosine alpha 2 is equal to 0. Now this can be simplified using trigonometric identity as cosine alpha 1 plus alpha 2 over 2 multiplied by cosine alpha 1 minus alpha 2 over 2 must equal to 0. Now you know that if I'm having two terms equal to 0, either one of them equal to 0 or two of them equal to 0. Yeah? Now this one is impossible.
For sure.
This one's impossible. Sorry, this one's impossible. Alpha 1 plus alpha 2 is equal to 0 is impossible. Why? Because the first thing, alpha is restricted between what and what? 0 and pi. Yeah? So if I add any values to 0, unless I'm using 0 and 0, which is the trivial solution. So this term, impossible to equal to 0, so this term must equal to 0. Yeah? So simply here, maybe I think I'm having space. Yeah. So simply, I will end up with cosine alpha 1 minus alpha 2 over 2 must equal. So simply this means that when the cosine should equal to 0, pi over 2. Yeah? Yeah, thank you. So simply, I will get the condition between alpha 1 and alpha 2 such that alpha 1 minus alpha. Did I do a mistake? Alpha 1, alpha 2 equal to pi?
Yes.
Pi over 2.
No, just a minute, just a minute.
Alpha 1 minus alpha 2 over 2 equal pi over 2.
Yeah. Just a minute. Alpha 1, let's turn back here, sorry, so just a minute. Now, the identity is correct, I mix it. Yes, check it.
Cosine sine.
No, it will be cosine. Let me check that. I have it. Okay. Now this is the cosine, yeah, it's cosine alpha 1 plus alpha 2 multiplied by cosine alpha 1 minus alpha 2 equal to 0.
بدون الأوفر 2.
With over, yeah, it's all over. It's my mistake, Let's see. Now, which term here, which term can equal to 0? Now, if this one, alpha 1 minus alpha 2 is equal to 0, now alpha is between what and what?
0
0 and pi. Yeah? And alpha 1. And alpha 2 is what?
Same.
Between
0 and 5.
0 and pi. Correct? So now, this means here, alpha 1 minus alpha 2 over 2 is impossible to equal to 0.
ممكن واحدة ألفا وواحدة زيرو.
No, no.
ممكن تكون alpha 1 باي
وألفا 2 زيرو تصير باي أوفر 2.
Alpha 1 is what?
إذا كانت ألفا 1 باي وألفا 2 زيرو
This one is also equal to 0.
تصير باي أوفر 2 تصير زيرو.
This one will equal 0.
Yes.
So this one, the previous solution for here. It's my mistake, sorry. So the only possible scenario that this term will equal to 0. Now if this term equal to 0, this means that alpha 1 plus alpha 2 over 2 must equal pi over 2. So we are reaching to alpha 1 is equal pi minus alpha 2. And this is the correct. It must be the complement. It must be the complement. So if I'm deciding, let's say the fairing angle for the first converter, already I find what? The fairing angle for what? I found the fairing angle for the other converter. So this is my mistake. I'm sorry for that. Why here I discover in this case alpha 1 will be greater than pi over 2. And this is impossible. That's why a flag rising and I reject myself and I did a mistake here, sorry for that. It's the age. The age? The aging phenomenon. The aging effect. Okay, so because I'm too lazy to do that, yeah, thank you. I will add here one.
Plus.
So I will end up with our magic formula such that alpha 1 equal to pi minus alpha 2. Yeah, good. So now let's see. I'm having two converters connected to anti-parallel configuration. And let's assume that this is the torque and this is the speed. And I need to specify the Q's, huh? I need to specify Q1 and Q2 for. Now, Q1 and Q2 here, which converter is responsible? Converter number 1. So here Q1, Q2. So simply here the voltage is positive or negative?
مرة positive.
Here.
Positive.
So alpha 1 will be less than pi over 2.
Okay.
And alpha 2 will be what?
Great.
Pi minus alpha 1. Yeah. Here the voltage is negative.
Yes.
Huh?
Yes.
So alpha 1 will be what?
Greater than pi over.
Greater than pi over 2, and alpha 2 will equal to what? Pi minus alpha.
Q4 مش Q4.
Sorry, Q4. Q2 with respect to IV can. So if this is the I V can, sometimes we say this Q and Q2. Whatever. Alright, yeah, Q4, thank you. Now this converter 1 responsible for Q1 and Q2. That's why I'm calculating what? In the first stage alpha 1. Then I'm finding or calculating what? Alpha. Now, what about here? This is the Q2, Q3.
Converter to.
The second one. So
I'll be having a negative current.
so simply the voltage here with respect to converter
To positive.
positive or negative.
No.
Positive. Positive.
With respect to what?
To the
Here.
converter.
Positive.
Positive.
Negative with respect
To the machine.
Negative with respect
Now this is the
With respect to
converter.
two, positive. With respect to one, negative.
This is the machine. Now here this is the plus and the minus for the reference. And now I'm discussing here V2, so this is the plus and the minus. Yeah? So here I need the voltage to be positive with respect to what?
Two.
To the motor, which is negative with respect to what? To the
Converter
converter.
to. Yeah.
Yeah? So simply alpha 2 is what? Greater than
Then
pi over 2, and I will calculate what alpha 1 accordingly, which is the pi minus alpha 2. Here, alpha 2 is less than pi over 2. Why? Because here I need what? The voltage to be negative with respect to the negative voltage, negative current. Yeah? And alpha 1 to be pi minus alpha 2. Yes? Good? Do you have any question?
الفا 1 لما تكون اكبر من باي اوفر 2 الفولتج بيكون نيجاتيف صح؟ الفا 2 الفا 1 لما تكون اكبر من باي اوفر 2
Alpha 1. Yeah.
فوق
Yeah.
تكون اكبر من باي اوفر 2 بيكون الفولتج عندي بوزيتيف نيجاتيف سوري
Just a minute. Alpha 2 is greater than pi over 2? Here.
الفا 1
Just a minute. Here I'm deciding the converter for the second converter. So I'm deciding alpha 2. Yes? Follow with me. Alpha 2 higher than pi over 2? Alpha 2 is greater than pi over 2? Then alpha 1 less than pi over 2.
اوكي صح
They are set together. I must obey alpha 1 plus alpha 2 is equal to what?
pi.
To the pi. But simply, in order to make it very simple, I'm saying that I will calculate alpha for the converter which is responsible for the mode of operation.
تمام
And the second one will be what?
The
The
complement.
complement. Yeah? So that's why here I'm calculating alpha 1. Here I'm calculating alpha 2. Then I recalculate or refine, let's say, the complement angle according to the one which is responsible for the Q's. Good. Okay. Do you have any question? Now, what about this four mode of operation? Huh? Can I support the four mode of operation using only one converter? Are you sure? Of course, I will reconfigure the converter.
اه really.
How? So I will connect what? I will connect the load between the midpoint. Correct? Yeah. In this case, I can now have what? The two ways or for the current flow. Correct? So this is also can be done
With H3.
either. Let's assume that I'm having switches. Huh? So this is the first switch, the second switch, third switch, fourth switch, and here I will connect what? The load. Yeah. Now, if switch, let's say S1, call this one S2, call this one S3, call this one S4. Now, if S1 and S2 are conducting, then the current, let's assume this is the plus direction of the current, huh?
Positive current.
Then this will be what? IA positive. Now, if S3 and S4 is conducting, In this case, what I will have?
minus I.
Yeah, the current will flow in the opposite direction. So in this case, IA will be in the negative direction. So in this case, I can rotate the machine forward or backward. So sometimes this will be called F1, F2, and this can be called as R1, R. Good. Do you have any question? This is the single phase configuration. Yeah? In the three-phase configuration, one, two, and three. In this case, I need to use the two converter and anti-barrier configuration. Now here I achieve what the midpoint. Huh? In three phase, I'm having third link here. So this is actually for three-phase system in this case. I don't have answers. I'll check it. I don't think it can be supported. Just a minute. No. I need three terminals. Actually, if this is a, let's say, IGBT or MOSFET, then the converter can be operated as a rectifier or an inverter. It depends on where I will inject the power. So the power can go from DC to AC or from AC to DC. Yeah. Now this one here, I'm having two midpoints. Yeah. So I can connect the machine in between. If I'm having three-phase system, I'm having 3 points. Yeah. Of course. Here, what I did, I reversed the direction, the input and the output. If I recall the first configuration, it was almost the same. Except that this is the output. Yeah? And this is what? The input, correct?
Yeah.
So what I did here, I reversed the configuration. In three-phase system, this is the output, and here the input. Yeah, I'm supplying the A, the B, the C, or the what you call the R, the S, the T. Huh? Now here I cannot reverse it, yeah? But I will check. I will check. Okay. Anything else?
دكتور الفولتج بهاي الحالة بقدر بالفور مودز اوبريشن اشغله بالاتش بريد
Yep.
بالفور مودز اوبريشن بقدر اشغله.
Now let's see, the four mode of operation will decide according to the voltage direction, the voltage polarity and the current. So now here the current can be positive or negative.
بس
Yeah?
الفولتج دائما positive.
Now let's see the voltage. Yeah? Let's see the voltage. Now if I'm having a waveform here, and let's assume that I'm firing less than 90. So this is alpha here, and it will be somewhere here. Huh? Now, this will be the plus. So S1 and S2 will be on here, correct? Yes? Yeah? So VT or this VA, let's say, will see this one, correct?
Yes.
Yeah? Then it will turn off here, correct? So the positive cycle is higher than the negative cycle.
Average positive.
So the average is positive. Let's the same configuration. Let's fire it in alpha higher than 90. Here.
Negative cycle.
So it will be somewhere here, the next direction, right? So the VA will be see this one, correct? Yeah? So this can support the forward. Yeah?
بس هاي دكتور هاف ويف مش فول ويف.
Yeah. So simply sometime here instead of the switches we are using contact. So instead of I don't think I don't have side. Okay. So it will be something like so it will be a contactor. Now this is called M, F or F, let's say, let's call it F1. This will call F2. This will call R1, and this will call R2. So F1 and F2 is for forward motoring. And M1 and M2 if on for sorry R1 and R2 if on for reverse.
طب مش لو الفولتج نيجاتيف بيكون
Reverse bias.
بيكون ريفيرس.
So simply all the time the voltage will be positive, which means that this one only just a minute. Just a minute. Now if alpha is than 90, then this one will be positive, correct? Yes. If alpha is less than 90, if alpha greater than 90, then this will be the area here higher than the area here. So the voltage is negative. What's the point?
قصدي F1 و F2 بيشتغلوا Q1 و Q4 يعني forward motoring و reverse braking.
Now, if F1, F2, it's a thyristor or what? This will depend on if I'm having IGBT. In the IGBT, I'm having freewheeling diode, which means that I'm having a flow for the current, a path for the current. If I'm having a thyristor, in this case, I have only one direction for the current. The IGBT is backed with what we call freewheeling diode. The freewheeling diode is used in order to provide a path for the current. Yeah? So now here, if I need to specify a negative current, a negative current can flow in the opposite direction, from here in this side. Yeah? So if I need to have regenerative braking, what we call regenerative braking, then the voltage must be positive. Yeah?
Yes.
And the
current
current is what?
Negative.
Is negative. Which means that I will control switch 1, switch 3 such that the positive cycle is higher than the negative cycle.
يعني بدي اغير الالفا
Yeah. Now here I'm having switches for S1 and S2 and switches for S3 and S4. Yeah? So simply
او مثلا بدي اشغل S1 و S2 بالفا و S3 و S4 ببيتا.
yeah. S1 and S2 if I need to operate in the forward motoring. And if I, so let's say it's alpha, certain alpha forward. So let's assume I'm having alpha forward in order to control S1 and
S4
S2.
S2
Yeah? Now, and if I need to control in the reverse direction, then I need to control the switch S3 and S4. Now, in general, we need to find a mathematical model for the converter. So if I need to design a controller, I need to find the, let's make space here. So in general, what I need to find a mathematical model for all the components I'm having. Now, if you recall what we have, the motor, and the motor, we have a model for that. The model is already, we have it, yeah? Yeah. We have either state space or Laplace. Yeah, do you remember it? If this one is VA, this will be the electrical part 1 over RA plus LAS. Here we call it KT, I think. This will be the TE. And this will be T load. Then after that, we have the swing equation, 1 over JS plus B. And this will be omega. And if I multiply this one by KB, we call it KB or KA? KA. So this will be the vacuum. Now, the first thing, any drive contains at least torque controller or current controller. In general, if I need to control, what I need to control? I need to control the speed of the machine. Yeah? I need to control the displacement. I need to control the torque of the machine. Yeah? If I need to control the torque of the machine, I need to control what? The current. So if I need to control the current, the first thing I must take a current feedback. So here is IA, correct?
Yes.
So this will be current sensor here. Yeah, I need current sensor, correct?
Yeah.
So we need to find a mathematical model for the current sensor, yeah? Now the current sensor here, it should compare by the reference current. Then this will go to where? To a BI control, current control. And the BI control will give me what? VC, control signal, VC. Now this VC, I need to find a mechanism in order to give it to the converter. Because the converter will provide the voltage for the machine, correct?
Yes.
Now, if I need to have a speed controller, in this case what I need here?
Like speed sensor.
Speed sensor. Now, I will compare it with the reference, omega reference, let's say. Then I will use a BI control, speed control. And the output of the speed controller is what? If we go to the torque speed characteristic, is the torque and this is the speed that is here. Now, if I change the speed, I will change what? The torque, correct? Yeah?
Yeah.
So this actually will be what? T reference. Do I have a relation between the torque and the current?
Yes.
Yeah, so actually, if this one 1 over KT, this will be a reference, yeah? Or simply someone will say this is a constant man. So this actually, all of that can be seen as the BI control. Yeah? So the output of the BI speed control is what?
Current.
Is the current reference. Because it's the torque reference. Yeah? Good. So now let's see. If if I need to find the mathematical model here, what I need, the machine, this is the machine, huh? The machine, I know the mathematical model for the machine? Yes. I need to find the current sensor, mathematical model. I need to find the speed sensor, mathematical model. The PI control, I know it. So the missing one is what? The converter. So next time I will start with you how to model the converter and how to find the mathematical model also for the current sensor and the speed sensor. Okay? Do you have any question? Next time I will give you quiz. The quiz, okay?
احنا مش
I know. So you will
ناخذ الكويز من الاثنين يعني
hmm?
الاثنين ناخذ الكويز ولا فيش الكويز؟
لا الأربعة أونلاين تدخل مساء enjoy.
في بالقاعة كويس يعني ولا كله اونلاين؟
لا راح يكون عندي كويز بالقاعة اللي حابين يمتحنوا.
شو مادة كويس طيب؟
في مواد كويز.
لا الشابترات كثير.
Chapter the previous lecture شو رايكم؟
اوكي.
The previous lecture was about what? The dynamic braking. What else? The plugging. The four mode of operation. The four mode of operation. I think we discussed four mode. Going from Q1, Q2, Q3, Q4. A gravitational load, bidirectional load, changing RB. Yeah? It will be something like that. Okay.